Our last to-doodle in the fraction category on our website is to talk about fractions and terms. Terms we'll define in a moment, but the connection to what we've been doing is anything you write as a fraction, whether it has just a single number on the top, like 1/2, or more complicated things like this one, we can make fractions with division. So I can always rewrite any fraction as a division problem. If I have a bunch of stuff on the top, I might have to put it in parentheses to show that that goes together. But anytime I have a fraction, I can just take the fraction bar and replace it with a division symbol. So in other words, fraction bars are just grouping symbols. They're like parentheses, they're like brackets. They say this 8 minus 4 is one thing, and this 3 plus 1 is another thing, and we're dividing the top by the bottom. So if I show you something like this, then maybe you start having memories of even longer expressions. That's in some past math classes. Your teacher said, you have to simplify these things. So let's talk about that, because we're not literally done with talking about fractions until we're also done talking about these kinds of expressions. You might have been taught an acronym named PEMDAS. It's over here if you know what this is. If you haven't, don't worry about it. PEMDAS is an acronym that talks about order of operations. If you have some choice, or what looks like it's maybe a choice, then which types of arithmetic do you do first? So let's look at this problem here. If somebody just wrote on the board 8 divided by 4 times 2, then it's usual, and if we haven't already talked about order of operation, that if I was to ask everyone what happens, I will get 2 different answers. Some people say we do this 4 times 2 first. Often these people were taught about PEMDAS. They're going down this list and they say M comes before D going down, so we will multiply before divide. If we did the 4 times 2 first, the 4 times 2 would turn into an 8. We'd get 8 divided by 8, and the answer would be 1. So you might not think this is right, but can you follow the steps here? The 4 by 2 turns into an 8, and then the 8 divided by that 8 is 1. If I'm writing it on the right, the 4 divided by 2 is 8, and then 8 divided by 8 is 1. Other students would say, no, we need to work left to right, like we're reading in English. If that happens, the 8 divided by 4 would happen first. 8 divided by 4 is 2. And then the 2 times 2 becomes 4. And you might not like that. You might think the first one is correct, but you should at least be able to sort of follow the line of thought. Everyone okay with understanding both of these, even if we know one of them is wrong?
Yes.
So if you understand them, tell me which one you think is right. You can type it in the chat. You can call it out. You could just take your pen and put like a check mark by the top or the bottom in your color, because you are on the same Jamboard.
I think the 8 divided by 4.
So the bottom one that starts with the 8 divided by 4.
Yes.
Yes. Okay. Is Josie right? What do the other people think? No, they are not as brave. Okay. So yes, that one is the right one. And if that surprises you, we need to talk about PEMDAS more. So I'm going to make a copy of this so I can write about it. So when I'm looking at PEMDAS, then it's telling me some good things. The first thing that I want to look at is parentheses and exponents. And we've also seen that fraction bars are grouping symbols too. So they're sort of all one thing up at the top. They're the thing we do first. Parentheses, exponents, fraction bars. And they aren't really something that says do this. They're just saying this is sort of separate from other things. Then the next step is to do all the multiplication and division. And why Josie was right was if we have both multiplication and division together, then we go left to right. That's what was happening here. We have multiplication and division together. And we have to say one first if we're making an acronym. We have to either write the M or the D first. But we're not really wanting to do that. They should be the same priority. And then lastly, addition and subtraction have the same priority and are the last thing. So there's really only three colors, only three steps. Pay attention to grouping symbols, do the multiplication and division, and then do the addition and subtraction. And if there are things that have the same priority, then go the way we read from left to right. That doesn't really help us though. If I look at some of these longer things, then I'm just not even really quite sure what to do. They're sort of overwhelmingly long. So we need a new tool. And that new tool is what we call terms. So a term is any part of an expression that is separated, if you put an equal sign at the end, only by plus or minus. So if I'm looking at this blue one, let me actually make some copies of this page. I want 3 of them. So let's grab this blue one and move it to where we have some room and look at it. Whoops, what happened there? It's trying to move just the blue one, not the. Copy, sorry about this. Okay, there we go. So if I was to say this equals what, I'm trying to simplify it. What does this equal? So to play the terms game, I start on the left like I'm reading. And I go, la, 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 la. There is a plus sign, but that plus sign is inside a parentheses, or so it doesn't count. I keep going, here is a plus sign that's not in a parentheses. So that breaks up this big expression into terms. Then I keep going, and I'm at the end. So this is one term, and this is the other. And the magic of terms is that these two pieces are going to stay separate until the very end. So I can think about them separately. I can even, if I want to, draw a box and just cover up that because who cares about it? Let's only look for now at this 4 plus 2 and then divided by 3. Where would I start with that? And Josie called out last time. Cody, Haley, Jaden, somebody else be helpful. So yes, 4 plus 2 is the thing we do first. That's what's in parentheses, and parentheses are in this green mess. So 4 plus 2 is 6. And then we will do a divided by 3. What's 6 divided by 3? 2. So that's this term getting simplified. Now we can say, oh, what was over here? And unfortunately, I don't cover up my writing with Jamboard boxes. Actually, I can do that. One moment. I can say, just need a big square. Ah, now I have a square that will, no, that also doesn't work. Never mind. Okay. So I have to pretend I'm not looking at this stuff. I'm just looking at the 8 times 2. So what is 8 times 2?
16.
16. And then this plus sign that was separating the terms keeps coming down. And the 16, it stays a 16. We're done simplifying that early. So what is 2 plus 16? 18. I'm going to erase this equals question mark. That's probably not what you would ever write. So again, the goal is we're going to break things apart into terms, find all the plus and minus that are not in parentheses, and they just go all the way down the problem. Then each term we can deal with completely separate from all the others. They're independent issues. And at the end, there will just be something with plus and minus. And we can handle that. I'll do the second one, and then you can help me with the third. Sound good?
Yes.
So the second one, see if I can copy and paste correctly this time. So this looks big and scary, but it's not if we treat it the right way. So let's break apart the terms. Here I go, my turn. I'm going to start here. I need a plus or minus. There's a plus or minus. So this minus is just going to keep happening all the way down. Then my second term, I keep going. That's in a parentheses. That's not a plus. Ah, here we go. This plus is just going to happen all the way down. And then 5 is its own term. Everyone okay that this has 3 terms?
Yes.
Yes, it's like I'm cutting a brownie. Wherever there's a minus or a plus outside of parentheses, I slice it there. So, well, the 5 is just 5. I don't have to think about that one at all. How about this one? 1/2 times 4 times 5. I'm doing multiplication and division. So I'm going to go left to right. 1/2 of 4. Well, 1/2 of 4 is just 2. And 2 times 5 is 10. Maybe I need to keep going. Now we have the middle term. I start with what's in parentheses, because that's up here with the green stuff. So the 3 is going to stay there. 9 minus 1 is 8. Now I have just multiplying and dividing the blue stuff, so I'm going to go left to right. 3 eighths, well, 8 and 8 is 16, and another 8 is 24. And then 24 divided by 4 is 6. So I've made it to the bottom. All three of my terms I have turned into just a number. If it could do it immediately, that's fine. I just keep carrying that number down. At the end, I have this nice problem that's much easier. 10 minus 6, well, that gets me down to 4. Plus 5 is 9. Questions about that example before we move on? Okay, time for either Josie or other people, if they've gotten back from grabbing food, to show off, because this one is even bigger. Okay, I have a pen and you don't, Josie, so you boss me around. I'm going to start underlining the first term. Tell me where to stop.
Stop.
So this minus breaks things apart. I'm going to guess we need 3 rows. I'm not sure yet. Okay, again, tell me when to stop.
Stop.
There's a plus outside of parentheses, so that's going to break things up. Okay, here I go.
Stop.
That minus and now we're at the end. So how many terms does this problem have?
4.
4. So pick any of them. Kind of most people pick the one on the left first just because we're used to going left to right, but they are all independent. You can start wherever you want.
19 minus 4.
19 minus 4. And the divided by 3 is just kind of waiting there. Whoops, 15.
14 divided by 7, or do I have to keep going down that row?
Let's finish one. If you jump back and forth, you can, but that's a great way to miss points on a test. When our brains are not working because we're always panicking on a math test, then we're going to have some bad situation where we forget to go back there and mess something up. So once you start one, it's just a good habit, even if it's not necessary to finish it up.
Okay, so then it would be divided by 3, it's 5.
5, yep. I guess I don't need my other row. Okay, next term.
So the 14 divided by 7.
Yeah, so 2 7s make 14. Okay.
And the 8 times 2. And then the 90 divided by 9 is 10.
Okay. Then at the end, I put these all together. So what do I have? 16. Then I have $16. I pay someone $2. So now I'm down to 14. Someone gives me 5. I'm up to 19.
It's 9.
I spend 10. Yes, it'll be 9. Okay. Ta-da. So this looked absolutely terrible, but it actually wasn't that hard. It took a little while, but it wasn't kind of tricky. It was just long, if that makes sense as a difference. I would certainly much rather do this than a big long division problem or something like that. Where do we get terms in real life? We get them with lots of area puzzles. And by puzzles, I mean we have more than one shape touching each other. This house kind of thing has a square and a triangle. We can do these kinds of problems. We need to remember the two formulas that are most common for area. Whoops, that says square. It should say rectangle. So the area of a rectangle is length times width. We have seen that a lot when we looked at other jam boards. One moment, let me grab one. So this kind of shape we've seen a lot. If we have 2 and 3, that makes 6. We can think of it as 2 3s. We could think of it as 3 2s, but it makes sense that length times width is how many, because that's just kind of how the counting works. So there's nothing magic at all about the area of a rectangle is length times width. The area of a triangle, if I have this triangle, then you believe me. You say, oh, all of length times width would be the whole rectangle that surrounds it. Length times width. And this triangle clearly covers half of that. So it's half of length times width. For some unknown reason to me, it's traditional with triangles to say base and height, but we don't even have to do that. It's just the length and the width of the rectangle that goes around that triangle. This other triangle, this one, I have to convince you more. Is this one really half of the rectangle that surrounds it? Maybe, but it's not nearly so obvious. So what I will do is steal something from underneath it. Oops, no, you come over here. So I'm going to take this piece, cut it off with a scissors, and put it there instead. And when I do that, now you can see that that is an upside down version of this one. In other words, yes, this blue triangle is half of the whole rectangle because the red part and the blue part are the same. Do you believe me? Did I do a good enough job explaining that?
Yes.
So those are all we need for now. There's other area formulas, but we're not going to use them today. So if I try and do these types of problems, I will get terms out of them. So I'm going to make a new page so we have some room to write. And oops. Then let's do this one. When I do these sort of area problems, and this is the kind of problem, by the way, that the GED loves because it sort of has more than one step, then I always do the same steps. And you don't have to. There's no official math rule that says the way my teacher does this is the only best way. But it keeps me from making careless mistakes. Because just like everyone, you've seen I make careless mistakes because I'm teaching or taking a test or whatever. So I'm going to start by writing an equation that doesn't even have any numbers in it. It's that the area of the house is the area of the square on the bottom plus the area of the triangle. And since I'm someone that's done a bunch of math, I have been trained to use subscripts. but however you want to write it, I'm making a plan. So this is step one is my plan. There's no math in my plan. It's just saying I'm going to take the square, however much that is, and the triangle, however much that is, and then I put them together. Good so far?
Yes.
Now I'm going to say I need some colors. Let's make this a blue square. And let's make this a green triangle. So that my next step, I want to take my plan and put in the formulas. So what's the area of the square? It's a kind of rectangle. It's length times width. If you just want to do L times W, because you're that kind of person, you can. And then how big is the triangle on top? That one is 1/2 times length times width. Now you have to write tiny to make it fit. Okay. Look, we have terms, right? This is one term, there's a plus, and that's another term. It's exactly the same thing as what we did over here. So step two is to put in my formulas. It's almost true that I don't have any numbers yet. I have a number just because it's in the formula, but I haven't looked at how big my shape is yet. None of these inches measurements have happened yet. This is all very general. All I know is I have a box and a triangle and I'm smashing them together. Good so far?
Yes.
Okay, so now I care that it's this particular box and rectangle. Let's put in the measurements. So I do one term at a time. It looks like this thing I've been calling a square actually isn't. It's shorter across than it is tall. It is 10 by 12. It doesn't matter which one is length and which one is which. And for the triangle, I need the height of my triangle. How tall is that line? It's trying to trick me, but I can figure this out. Anyone see it before I spoil the answer?
It's not 10 plus 12, right? Or is it 18?
The 18 goes all the way from the ground to the top of the roof. I just want the roof part.
So it's
If-
like half of 18?
Not quite half, because I know how high a ladder would be to get to the bottom of the roof. That would be 12. If I've gone up 12, how much more do I need to get to 18?
6.
6. Yes, that part is kind of tricky, but that's 6 inches. Remember how much more was a subtraction? We were talking about how to know which arithmetic thing to do. So 6 and then 10 is the other triangle number. The bottom of my triangle is 10, the height is 6. So I have a 10 and a 6. And again, it doesn't matter which is which, because I'm just talking about the rectangle I imagine around the triangle. Okay, now I have my two terms. I simplify them. I am happy. 10 times 12, that's just put an extra 0 on that 12. Half of 10 is 5. 5 times 6 is 30. And when I add them up, I get 150. As a side note, since it's a picture problem, I should label my answer. So I have inches, this is area, so I have to do square inches. If that's something that doesn't make sense to you, that it's square inches, don't worry, we'll talk about area as a different topic later. But I just want to do it right. If you just put 150, good enough for now. So ta-da, blue term, green term, they're totally separate. At the end, we add them up. I should finish labeling. So step 3 was put in the measurements. And you can do these same steps again and again with these other problems. The house, or is that a bank? It looks more like a bank. Anyway, the office building one is kind of interesting. You're trying to find the size of the sidewalk, and this little square there gets in the way. That one, it's actually much easier if you do a different picture. If I look at that picture, you will see, moment, that it looks too fancy, but I could actually redraw it like this one here. All I'm trying to figure out is the purple shaded thing, how much sidewalk goes on two sides of this bank or office building of some sort. So I have some in front, that's here, and I have some on the side, that's here. Do you want to solve this one together? Should we do it again?
Yeah.
Yeah, okay. So I'll write in my steps. I'm going to move these up a little so they're not in my way. And I was using red. So we have plan, measurements. No, not measurements, formulas. Measurements, and then get the answer. With this particular problem, when I ask students how to find this purple L shape, there are two good ways to do it. Some people break it down into 3 rectangles. Oh, come on, I can draw better than that. Here. So there's kind of a long up and down one. There's kind of a long side to side one, and then there's the corner. Some people break it down into 2 rectangles. They include the corner with one of the others. And then some people don't do either of those. They say, oh, we have an outside rectangle that's kind of dark blue in this picture. And then we're subtracting away the green rectangle. It's like we have a cookie cutter and the purple is the dough, and we just took this off with the cookie cutter, and what's left is that L shape. Do you have a preference on which one to do, Josie? They all work.
I think the cookie cutter one that you said seems a little bit more easy.
Okay. Different people's brains like different things. The cookie cutter one is nice because I only have 2 things to work with. The one that has 3 pieces is a little longer because you have 3 pieces. So I'm going to say that my plan is the area of the L shape is the area of the big blue. I don't have purple. Minus the area of the smaller green. Happy so far?
Yes.
So they are both rectangles. They're both going to be length times width. If you just want to write L times W, great. I'm not sure why I am writing so much, but that's okay. And then finally, how big are these things? The outside one is 113.4 times 75.4. Those decimals aren't scary. My calculator can handle that. The inside one is 110 times 72. So I will go get my calculator. There we are. First, I want to do 113.4 times 75.4. 113.4 times 75.4. So 8550.36. And then 110 times 72. So 7920. And then finally, if I subtract them, what do I get? So I want 8550, whoops, 0.36 minus the 7920, 630.36. And at this point, if that was your answer, great. I'm going to label it square feet because that makes sense to me and I want to finish it. Cover up the other number. Questions about that one?
No.
So you can see the terms happening. A very reasonable question is, hey, this is like too much typing on the calculator. Calculators these days could do everything all at once. I could say, I'm going to take that and subtract that. And look, I get the same answer all in one step. And yes, that's true. The calculator can read the whole expression all at once. Even if it's a long one, I could type this whole thing into the calculator and it would give me the same answer that we did. So why do you want to learn these? Just because it will help you when you get to more advanced stuff. This mental habit of breaking things up into pieces and dealing with them separately will work, even if something in here isn't a number that's nice like 110, but maybe in a algebra class, that's an X or that's a Y. And now the calculator doesn't help me because it does numbers, not X's and Y's. So it's good to think this way, even if you could just do it all right now with a calculator. The last one is a little different. It gives you all of the outside measurements and you're trying to find the area of this one. You don't really care about the area of those two. And these types of puzzles were made famous by someone named Naoki Inaba. And you can go to his page and see lots of them. Here is one more, just if you're interested in that kind of thing. And he has a book of them. So if you have a relative that likes these sort of puzzles, then there you go. Now you know what to get them for their birthday. I'm not going to do this one now. I want you to have something, since it's Thursday, to play around with that's new for exploring, checking your understanding. Let me know on your checklist which things are worth doing and not, because remember, you grade the homework. But this is a little different. In this problem here, you know both areas. The whole thing is going to be 10 plus 6 is 16. But how much is the side? Questions on any of that? We did a lot of good work.
Could you do the, you know how you said that, which would be easy, like the cookie cutter or the one that had like the 3? Could you show how you would do like for the 3, I guess?
Sure. Let me grab that shape and make a duplicate. Clear that, paste it. Okay. My colors are going to be a little off, so let me try and draw this better for what pens I have at my disposal. So I have a blue shape here. I have a green shape in the corner. And I have a red shape there. Those are my 3 triangles. Make sense so far?
Yes.
So my plan, oops, stop using funny pen. Okay, so my plan is that the area of that L is going to be the area of the little blue rectangle plus the area of the tiny green square, and then plus the area of the tall red rectangle. With me so far?
Yes.
Okay. I'm not going to have room to write the words length and width 3 times, so I'm just going to go L times W. And I habitually do my L's in cursive, because sometime in my personal history, I wrote the L's like that, and it looked like a 1, and I got the problem wrong. So I now have the habit of, oops, I should color code them too, of writing my L's as cursive L's so that I don't mess up like that again. So L times W. L times W. And you might think, teacher, what do I do if I don't have all these fancy colors because I'm on the computer screen? Then maybe I would put some sort of shading on one of them and just sort of remind myself that's the shaded one. Or I might just have colored markers or pens, or colored pencils, because that actually helps a lot. Okay, so that was my plan. That was the formulas. Now I need to plug things in. How big is the blue one? It's 113. No, it's not 113 because that goes all the way across. And we're stopping early, right? We're not doing this last little green bit.
So it's 110.
So it's just the 110. And then how tall is the blue one? Well, the whole edge is 75.4. Going down this far is 72. So this must be the other 3.4. 72, and then a little more to get to 75.4. So times 3.4. Then how big is the green one? We just saw that this is 3.4. What's that little edge?
Is it 3, 4 again?
It is. This distance goes 110. Then we go a little bit more to get to 113.4. So it's also a, whoops, I put 3.3 because I made a mistake. Okay, 3.4. And that kind of makes sense that the sidewalk would be the same width on both sides of the building. So 3.4 times 3.4. And then this one, how tall is it? That was the 72. And how wide is it across? That was the 3.4. Now, once again, I could put all of that in my calculator in one long line and it would do it. But I'm going to pretend that it helps me to do it step by step, you know, each of these three terms separately, just for that good habit for when I get to algebra later. So 110 times 3.4, 374. .4 times itself, 11.56. Whoops. And then 72 times 3.4, 244.8. Okay, did I transfer all of those correctly? Looks like I did. Okay, finally add them all up. And what do I get? The 374 and the 11.56 and the 244.8, 630.36. Surprise, same as before. Variable 6. Oh, okay. Be a 6, not a smudge. Questions on that now that we did it?
No.
I bet you can do this one in your head. We can see the hint I gave you before that when I put these together, I have a total of 16 for my area. So if one edge is 2, what's the other edge going to be?
Two.
It's not 2. You can first of all see that this is shorter, so it's not going to have the same, but also 2 times 2 is 4. We want the area to be 16, not 4.
Is it 8?
It is 8. 2 times 8 is 16. The fact I have 2 colors and stuff doesn't matter. I'm just saying, what is a rectangle where the 2 edges are 16? Multiplied to 16. One edge is 2. What's the other one? Ta-da! Let me see if I can show you this website, because it is kind of fun. So there's the one we just did. You can see some others. And then when you're done, you can pick like harder ones. And at the bottom, you can check your work. Or you put your number in here and then check your work, things like that. So if you like these puzzles, then there are more. Okay, thank you, Haley, for checking in. Okay, I'm going to stop recording on this one.